Good morning, everyone. Hope all is well. Hope everything is all right. Okay, I think everybody's in here. Okay, cool.
Good morning.
How's it going? How's it going?
All right. Before you get started, can I request a like I told you I don't understand like all of the symbols that are on the calculators, all of the symbols that are on different thing. The terminology is can you direct me somewhere that will help me to familiarize myself with the things that I don't know?
Yeah, stay back after class so I can see what symbols and stuff you're talking about, and we can go from there.
Okay.
Yep. Don't let me forget though. Don't let me close out without having that discussion with you.
Well, not. Thank you.
All right. Anybody else? Any other general questions or concerns? Everybody good? All right. We gotta pull up this. All right, let's see, where did we leave off last class? This is 130. Did 1-4.
Now remember, everything is 2 something for us. It's not chapter 1, it's chapter 2.
Yeah.
And we're going into chapter 3.
Yeah. Thank you, sir. Thank you, sir. Appreciate it. Let me make sure this coincides as well. I had to reset my computer for this class. I don't know if it was Zoom or my computer acting up my last class, so I had to reset everything. So and somebody said Zoom was acting up a little bit today, but I don't know if that was the case. So
It was acting up earlier today for me as well.
oh, okay, cool. So maybe it wasn't my computer then. Appreciate it. So hopefully we won't have any issues. Where are my assignments? There we go. So, yep. So we're looking at 2-1. Well, I went into the wrong shell. I forgot you guys have a new one. I need to get that one off of my class thing. I think everybody's good now. All right. So, we did 2-5 last class. So now we're looking at the simplifying algebraic expressions. And right, Mr. That is Tucker, right? That's it. Because I think I saw that your last name was Tucker through the email. Because it's not Tucker up here. Yeah.
Yes, sir. It's just the name of my computer. It's my business name.
Gotcha. Yeah. So yeah, we're looking at simplifying algebraic expressions, but as he said, that's going to be 3-1-4. It's not 2-1. All right, so that's 3-1. All right, so simplifying algebraic expressions. I can go to write that algebraic out. So first thing I want to make sure we're okay with is the idea of having like terms versus unlike terms. So these are terms that we can add and subtract from each other with no problems, without any issues. So if we're going to have like what we call like terms, then they have to have the same variables, same amount of variables, same exponent on your variables. If anything's different, then they are considered unlike terms, or they're not like terms. So this first category, first column, 3x and 5x like terms. Negative 10x y, 8xy will be like terms. 21x squared y, negative 100x squared y would be like terms. And then 7 and 11, numbers that we normally deal with without any variables at all, would be like terms. Now, if anything's different, then they will be unlike. So when you look at 3x and 5, you cannot add those together. They don't both have x, so they're not like terms. Here, negative 10x and 8y, 2 different variables, so they're not like terms. And then here we have xy in the first term, x squared y in the second term, so they're not like terms. Once again, if anything's different with the variables, or your exponents, then they would not be considered like terms. And you cannot add them or subtract them from each other. All right, can I scroll up? All right, so in the red, we just have a few examples of when you could add terms together, when you could not. And if something changes, you know, how that affects what's going on. So in this first one, 5x and 3x, 5x plus 3x will be 8x. You can add those together. They both have x. 5x plus 3y, there's nothing you could do with that. So you can go ahead and say that that expression is already in lowest terms. All right. 5x squared plus 3x squared. You can add those together. They both have x squared. That will be 8x squared. 5x squared plus 3x is already in lowest terms. And then the last one, 5x plus 3 is already in lowest terms. Any questions? All right, so here we have 2x plus 5 plus 3x minus 2. Those directions just say simplify. So you would combine your like terms. 2x plus 3x is 5x. And then 5 minus 2 would be 3. So 5x plus 3 would be your answer. All right, next one. Probably should put some type of divider there. So next one we have negative 5a minus 3 plus a plus 7. So once again, you just combine your like terms. Negative 5a and a. So don't forget, when you don't see anything in front of your variable, they assume you know there's a 1 there. So that's why I was putting that notation. So negative 5a plus 1a will be negative 4a. And then negative 3 plus 7 is a positive 4. All right, next one. We got 5a times the quantity of 3x plus 2. So you just distribute the 5. And that'll be 5 times 3, which is 15x. 5 times 2 is 10. Next one, distribute negative 2 into the parentheses first, and then negative. This negative is the only thing that goes, the only thing that's sitting in front of parentheses. So you treat it the same way you would a number. So negative 2 times 4 would be negative 8. Negative 2 times 7 is negative 14. Negative times 3x is negative 3x. Negative times negative 1 is positive 1. So any problems with that distribution before we combine our like terms?
So why wouldn't you combine your like terms before you did your distribution?
Well, because the parentheses are there. So,
Would you get the same answer if you combined the, or would it not be
well,
the
that's what I
same
was about
answer?
to say. You don't have access to what's in the parentheses until you distribute. See, right
Okay,
now,
okay.
yeah, so that's the way you want to kind of look at it. Right now, the parentheses are there, and that -2 prevents you from doing anything with anything inside of that parentheses. Now, once you distribute the 2, now the parentheses is gone because what was holding the parentheses there is that -2. And the same thing with that negative sign that's sitting in front of the other set of parentheses. The parentheses is there, and what's holding it there is the negative. Now, once you distribute the negative, now you have access to what's inside of the parentheses.
Okay, I get it. I got it. Thank you.
No problem. Good question. Good question. Yep, yep. All right. So now you can combine your like terms, -8x, -3x, and -11x, and then -14, and a positive one would be -13. All right. So the next one says write the phrase as an algebraic expression, then and let x represent the unknown number. So they don't want you to use just any old number. Make sure you use x. Well, they don't want you to use any old variable. Make sure you use x as your variable when you write these out. All right. So the first one says twice a number plus 6. So if you're going to twice a number, that means you're multiplying it by 2. And then it says plus 6, and that's the addition of 6. So that's why we have 2x plus 6 to represent that expression or that sentence. Next one says the difference of a number and 4 divided by 7. So the difference is subtraction. So it's the difference of a number and 4. So it's going to be x minus 4, and then divided by 7. So you can write it, still have my eraser on. All right. So you can write it this way or this way. Or you could even put a slash right here. All right. Any problems? Any problems?
Why'd you put the parentheses around the x minus 4? Did you have to? Could it just
Yes.
be?
And the reason being is because if I were to do that, that's x minus 4 divided by 7. So now the division is only applied to the 4.
Okay.
But
So
when you
you're just making sure that it's done in the right order of operation. So you're
exactly,
prioritizing it. Okay.
exactly, you got it, most definitely. All right, next one. 5 added to triple the sum of a number and 1. Erase these circles for a second, just so you can see what we have here. 5 added to triple the sum of a number and 1. Excuse me. All right, so if you want to triple something, that means you're multiplying it by 3. And then the sum is addition. So you're talking about the sum of a number and 1. So let's look at what we have here. 5 added. Why do I keep leaving that eraser on? 5 added is pretty much self-explanatory. You're adding 5. And that's this piece right here. and then we're going to triple the sum of a number and one. So we got the number of one, the number and one. We're adding those together, and then we're going to triple that. So that goes back to what your classmate was just mentioning about emphasizing what's in the parentheses first, or emphasizing the addition of the number and one, and then you're going to triple that. So that's why you have to use parentheses. Now here, if you were 3x plus 1, now you are tripling x and then adding 1. But what we want to do is triple the sum of the number and 1. So that's why we had a parentheses around x and 1.
We got to get access to that number before we can do what we got to do to it.
Yes, sir. Most definitely. Now, and then I will say this too, you don't have to simplify this any further, because this was just writing the expression. They would tell you in the directions, simplify. And that's when you know you need to distribute and do stuff like that and combine like terms. But this, we're just writing the expression. So you wouldn't even have to go any further than this right here.
How could you simplify that?
Oh yeah, you can distribute the 3.
Oh,
And,
okay.
And then, yeah, and then go here, combine like terms, stuff like that. But like I said, this exercise didn't call for it. So. All right. Anything else on that before we go to the next thing? Make sure we're good.
Can you simplify that for me real quick? Because you just wrote something that
Yeah, not a problem. Everybody good? I scroll up and get some room. Everybody okay? Everybody okay? All right. So what we had was 5 plus 3 times x plus 1. That's what we had. Yeah. So you distribute the 3. And then you will add 5 and 3, because those are your like terms. And the result would be 8 plus 3x. Or you could write it as 3x plus 8. Either one of those is fine.
okay.
Long as the 8 is positive and the 3x is still positive. Yep.
I got it. Thank you.
Yep, not a problem. And just re-emphasizing, guys, this exercise didn't call for you to simplify. That was something he was just asking about, and I don't have a problem doing it. But but just remember, if you were to put in this answer, they may mark it wrong because they didn't ask you to simplify in this, exercise. So just throwing that out there. But that was just something that he wanted to see. So just making sure you guys are cool with what's going on. All right, questions on that before we go to the next piece. All right. So that was 2-1. That was under 1-4, right? Okay. Let's see what's going on here. I don't see why I didn't start off. Hold on one second. This didn't start off. We're talking about addition, multiplication property, solving linear equations, 2, 2, 3, introduction to problem solving. Okay. I wonder why I didn't start this off. Okay, let's do this. Let me go to another page of notes, start you guys off right. Okay. All right, so for you guys, like I said, I don't know why I didn't start your notes with that section with, solving equations from the beginning. Matter of fact, this is what I do. I write myself a note. Let's go to 130. MDE 60. 60, 4142. All right, guys, just want to make sure my stuff is straight. All right, so for you guys, this is section 3.2. So we're talking about adding in addition and multiplication properties of solving equations. All right. So first of all, make sure we're good with what an equation is. Equation is a statement that two algebraic expressions are equal. Two algebraic expressions are equal. So simple example of an equation is x plus 5 is equal to 12. I'm 12. X plus 5 equal to 7. So now when you're solving them, you're asking yourself, when is this statement true? When is this equation true? And that's going to be the solution. When you answer that question correctly, you have the solution. So that will be a value or value that will make that equation true. So in this case, it's going to be x equal to 2. Now you will always be able to check your solutions by plugging them back into your original equation for that variable. So if we have x equal to 2, I can plug it back in to x into the original equation. 2 plus 5 is equal to 7. And that's our true statement. All right. So when is the statement true? That's when x is equal to 2. Yeah, so. All right, can I scroll up? All right, so we will be solving by what I call opposite operations. They're operations that undo what the other one does. So you have addition and subtraction. They undo each other. And you have multiplication and division, which undo what the other one does. All right. So going back to the x plus 5. So first thing we want to recognize is that our equal sign separates our equations or divides up our equation. It sets up the left side and the right side of our equation, left side our equal sign, right side of the equal sign. So that's going to be established by your equal sign. Now you want to undo what's being done to your x or to your variable. Your goal is to get your variable by itself. You want to undo what's being done to it in order for that to occur. So we have x plus 5. So to undo the addition of 5, I will subtract 5. Now, the reason why the equal sign is important is because whatever you do to the left side of your equal sign, you have to do to the right side in order to keep the equivalency. So if you're going to do an undoing of an operation on the left side of the equal sign, you have to undo it on the right side as well. So if I subtract 5 on the left, I subtract 5 on the right. 5 and negative 5 cancel, leaves me with just x on the left. And then on the right, 7 minus 5 is 2. And that is my solution. All right, questions on that? Excuse me. All right, so we'll do a few more one operation problems to make sure we're okay. Then we'll add more to it. So y minus 10 equal to 15. Your goal is to get y by itself. So you want to undo the subtraction of 10. So that means we will add 10 to both sides of our equal sign. Y is going to be equal to 25. The 10 cancels on the left. 15 plus 10 is 25 on the right. All right. Next one, 5a equal to 15. I said 15, 13. So 5a is 5 times a. So we'll divide both sides by 5 in order to cancel out the multiplication of 5. A is equal to 13 over 5. Did I write it up here? Yes. All right. So now that 13 over 5, you do not have to go any further than that. You don't have to convert it to a decimal, and you don't have to convert it to a mixed number. But you are expected to reduce. Now, don't confuse reducing with turning it to a decimal, converting to a mixed number. Reducing is this process down here, wherein, for example, if I have 4 over 6, and 4 is 2 times 2, 6 is 2 times 3, I can cancel out the 2's, and the lowest representation of that 4 over 6 is 2 over 3. That's reducing your fraction. So this you are expected to do. But notice I left it as 2 over 3. I didn't convert it to a decimal, 0.6 repeated or anything like that. So you don't have to convert it to a decimal. You don't have to convert it to a mixed number, but you are expected to reduce where possible.
So why don't we have to convert that to a mixed number?
Because they feel like you're pros at that now. We're moving on to other stuff.
Okay, all right,
Yeah,
good enough, gotcha.
But yeah, that's pretty much the only reason. Now I will say this, you can convert it to a mixed number if you want to. I know some people just had this thing where I got to convert to a mixed number, but just understand you are human. You give yourself more steps, then you give yourself more chance to get something incorrect. You know what I mean? So that's for anybody, so if you can stop right here, then, go ahead on to the next problem. But if you convert it, if you have this as a part of your process, but then you convert it to a mixed number and you make a mistake, and let's say you write 1 3/5 as your answer, well, that's wrong. And that's going to be your wrong answer. You know what I mean? So if you don't have to, then I wouldn't suggest worry about it. But if you do convert to a mixed number and it is correct, it still will mark it.
Are there any instances where it's going to tell us to do that, or is it always going to let us just leave it improper?
Yeah, at this point they'll let you leave it improper.
Okay, all right.
Yeah. Now a preview, like the classes before this one, then you would have exercises where it would say in the directions, convert final answer to mixed number or convert final answer to decimal. But in order for them to hold you to it, it has to be in the directions.
Okay.
Yep. So last one of the one-step operations, and I left my eraser on again. Right here, we have x over 9 equal to 11. So we have x being divided by 9. So what we need to do is multiply both sides by 9. Doing that will leave you with just x on the left, and then 11 times 9 is 99. And that would be the answer. All right, any questions before we do a little more? All right, hold on 1 second. Yep, that's good. We'll do that. All right, just want to make sure my notes are matching up with what I have here. All right, these are just. All right. All right, so let's look at this one. We have x plus 1/3 equal to 3/4. Just in case you do see a fraction one like this. So we can subtract 1/3 from both sides because we want to get our x by itself. So the 1/3 will cancel on the left, leaving me with just x. Don't forget, whenever adding, subtracting fractions, you need a common denominator. So that's what I did over here. So my LCD is 12, because the 4 and the 3 that's in the denominators of each. So that's the smallest number that both 4 and 3 can divide into evenly. So then from there, if you're saying your LCD is 12, that means you want both of your denominators to be that. So then you ask yourself, what times 4 will give me 12, and that's 3. So you multiply top and bottom by 3. And then what times 3 will give you 12? That'll be 4. So you multiply top and bottom by 4. That end up giving you 9/12 minus 4/12, and that'll be 5/12. That's your final answer. Any questions? All right, I'm going to erase some of this stuff. All right, so this first one, we have 2x plus 1 equal to 5. So now we have more than one operation being applied to our variable. So we're going to have to do more than one thing in order to get it by itself. Now, we could, if we wanted, divide both sides by 2, but then that's going to create fractions unnecessarily. So that wouldn't be our most efficient move. The best thing to do would be to go ahead and move the 1 first. So subtract 1 from both sides. 1's cancel, and that'll leave me with 2x on the left. 5 minus 1 is 4 on the right. And then divide both sides by 2. X is equal to 2. 4 divided by 2 on the right, give you 2. Okay, on the right, we have 6p minus 1 equal to 17. This time we'll add 1 to both sides. 1's cancel, leave me with 6p equal to 14. Divide by 6. 6 is canceled on the left, leave me with p equal to 3. 18 divided by 6. All right, questions? Any questions? All right, can I scroll up? All right, so on the next one, all right, we have 6x minus 5x plus 4 equal to 19 minus 9. So notice we have like terms that are on each side of the equation. What I would do is simplify as much as I can on the left, simplify as much as I can on the right before I move things across the equal sign. So, you know, when you move things across the equal sign, then you have to do opposite operations. But before you do that, you can simplify as much as possible on each side. So on the left side, 6x minus 5x is 1x. So that's why we have x right there. And then plus 4, still there. And then on the right, 19 minus 9 is 10. So we have x plus 4 equal to 10. And then finish it off by subtracting 4 from both sides. X is equal to 6. All right. Any problems? Okay. Next one, we have 5x plus 33 equal to 4x minus 16. So notice the difference between this one and the last one. This one, we have 5x and 4x. We have our two x terms on different sides of our equal sign. Last time we had them both on the same side, so we can just easily combine them. So it wasn't a big deal, but this time we have them both on different sides of the equal sign. So what we're going to do here is, or what we need to do is get all of our terms with x on one side of the equation, all of our terms without x to the other side. Doesn't matter which term you decide to move first. It doesn't matter if you take the 5x to the right, or maybe you decide to do the 4x first and move it to the left, 33 or 16. It doesn't matter which one you move. As long as you do everything right mathematically, you'll still get the same answer at the end. So let's minus 4x from both sides. 4x minus 4x cancels on the right. And that leaves us with x plus 33 equal to negative 16. 5x minus 4x is just 1x plus 33 equal to negative 16. Now we can finish it off by subtracting 33 from both sides. And x is equal to negative 49. Any questions? Any questions? All right. All right, so the next one, I think you guys have a fraction one. Let me see. As a matter of fact, yeah, let's start over here. We'll do this one. No dear one, let's go here. So now this one has a little more involved, but it's the same thought process as the one in which we have terms on each side of our equation, and we'll be able to add them and subtract them from each other first before we move anything across our equal sign. So we have 2x plus 3x minus 5 plus 7 equal to 10x plus 3 minus 6x minus 4. All right, so once again, best practice is to get everything over here simplified as much as possible, then simplify everything over here as much as possible before you move anything across your equal sign. So over here, I have 2x plus 3x, which is 5x, and then negative 5 plus 7, which is 2. So that's why I have 5x plus 2. And then over here, 10x minus 6x is 4x. And then positive 3 and a negative 4 gives you a negative 1. So 4x minus 1. All right. So this is a statement that I said already, just in words now. Get all the terms with x to one side of the equation, all the terms without x to the other. So once again, it doesn't matter which one you decide to move first, or if you want to put your x's on the left or x's on the right. As long as you do everything correctly mathematically, you'll still get the same result. So here I decided to subtract 4x from both sides first. So 5x minus 4x is 1x. Then subtract 2 from both sides. But let me stop here. Let me say this. So as you subtract 4x from both sides, you had x plus 2 equal to -1. So the 5x minus 4x gave you that 1x. But you still have plus 2 equal to -1. Now, once you're in this position, you'll go ahead and subtract 2 from both sides. And x is equal to -3. All right, any problems with that? Very good. All right, so this next one right here. 0.1x minus 0.6x minus 6 equal to 19. So now if you want to, you can clear out your fractions. You don't necessarily have to. You can just work it out. I said fractions, decimals. You can just work it out with your decimals. Once again, you don't have to multiply anything by 10. You can just work it out. But if you decide you want to clear out your decimals, you could multiply each term by 10. Now remember, if you're going to do this, you have to multiply each term, whether it has a decimal or not. Multiply each term by 10. That's because both of our decimals were in the 10th place. So we multiply each term by 10. After you finish doing so, 10 times 0.1, it would just be 1x. 10 times 0.6 would just be 6x. 10 times 6 is 60. And then 10 times 19 is 190. So when you do something like that, every single term needs to be affected by the 10, or you actually change the value of the equation. All right, questions? Any questions? So next, combine your like terms. X minus 6x is a negative 5x. All right. So we got negative 5x minus 60 equal to 190. And then add 60 to both sides. So negative 5x equals 250. Divide by -5, your result will be -50 for an answer. All right, questions? Any questions? All right, next one. I think we got 3 more. Yeah, because that's coming out of the next section. Okay. So 3 more we'll be done with this topic. Just want to make sure you guys are straight. Now, if you have fractions, if you want, you can clear out your fractions. Here we have x over 2 minus 1 equal to 2/3 x minus 3. So now if you want to clear out your fractions, here are our steps. So first thing you would do is find the LCD of each denominator that you have. Remember, just like we talked about before, your LCD is going to be the smallest number that each denominator can divide into evenly. So we have 2 and 3 here. So the smallest number that 2 and 3 can divide into will be 6. So our LCD is 6. Next step is to multiply each numerator by that LCD, which is 6. All right, so whether it has a fraction or not, or decimal or not, make sure you multiply each numerator by 6. So now we can simplify. So the 2 that's in this denominator can divide into the 6 and leave you with 3. This 3 can divide into 6 and leave you with 2. So remember, we're trying to get rid of our fractions. And the way we'll do that is to be able to divide the denominators into our new numerators. So that'll leave us with 3 times x, which is 3x. 6 times 1 is 6. 2 times 2x over here. That's 2x. Hang on. Over here, that'll be 4x. And then 6 times 3 in the back will be 18. So this is our new equation. 3x minus 6 equal to 4x minus 18. All right, so now we can solve. Any questions before we do so? Everybody good?
Yeah, don't scroll all the way up just yet. I'm still writing down. I'm a little slow, man.
Hey, you all right? You all right? You can pause right here. Just let me know when you're ready.
All right, I'm ready to do the solving.
All right, sounds good. So we have x in both sides of our equation. Now our point, like we talked about before, point of attack is to move all of our terms with x on one side, all of our terms without x to the other. So we will subtract 4x from both sides. Once again, if you decide to move the 3x instead to the right, you still will be okay. You'll get the same answer eventually, just that we'll have different signs moving forward and all that good stuff like that. But it's all good. Doesn't matter as long as you do your math correct, you get the right answer. I decided to subtract 4x from both sides. All right. Subtracting 4x from both sides gives me negative x minus 6 equal to negative 18. All right. Now that I have x minus 6, negative x minus 6 equal to negative 18, I will add 6 to both sides. That gives me negative x equal to negative 12. Excuse me. And to finish it off, remember, we're not solving for negative x, we're solving for positive x. So I'll take that negative that's in front of my x, apply it to the other side. Same thing as multiplying by -1 or divided by -1. And negative to a negative for that 12 would turn positive. So my solution is x equal 12. Any questions? Any questions? All right, scrolling up. Very good. Still copying. Anybody? All right. Next one. Almost finished. Got a couple more. I think this one and one more. So we'll make sure you see all scenarios. So we have negative 2 times x minus 5 plus 10 equal to negative 3 times the quantity of x plus 2 plus x. So want to distribute into each parentheses so we can have access to each term. Negative 2, when you distribute to negative 2, that'll give us negative 2x plus 10 equal to distributed to negative 3, that'll be negative 3x minus 6 plus x. Combine your like terms. On this left, 10 plus 10 is 20. On the right, we have negative 3x and positive x, which would be negative 2x. All right. So we need to get all of our terms with x on one side, all of our terms without x to the other. So we're going to add 2x to both sides. So here we have to be careful. What often happens when you have a scenario like this, we will add 2x to both sides. And the side that we want to cancel, we let that cancel. But then over here, for some reason, we will write x equal x plus 20. But if negative 2x and positive 2x cancels on the right, then negative 2x and positive 2x should cancel on the left as well. So really what you should be left with is 20 equal to negative 6. So my point with that that statement is don't be afraid to let math happen, and don't put your own spin on what normally happens. Once again, if negative 2x and plus 2x cancels on the right, then negative 2x plus 2x should cancel on the left as well. So it is okay for your variables to cancel out completely. And that's what we have here. Now, depending on when you did your addition and subtraction, you may not have 20 equal to negative 6, and that's fine. But what we do recognize is no matter what you have, when your variables cancel, you should have a false statement. Even if you had 0 equal to 14, that's still a false statement. So what has happened here is that our variables canceled and we have a false statement. Okay, it's not about, don't get caught up in 20 equal to negative 6. That's not an answer. Those numbers could have been anything, but the result was my variables canceled and I have a false statement because 20, of course, is not equal to negative 6. So if your variables cancel and you have a false statement, your actual answer is no solution. All right, there's no value you can plug in for x that will make this a true statement. So if your variables cancel, you end up with a false statement, your answer is no solution. Questions on that? Scroll up, everybody okay? All right, last one. 3 times x minus 4 equal to 3x minus 12. So distribute the 3. That'll be 3x minus 12 equal to 3x minus 12. When you subtract 3x from both sides, this time our variables cancel on both sides, but this time it gives us a true statement. So you could have had 0 equal to 0, depending on when you did things, but bottom line is you would have had a true statement. 12 is equal to 12.
This is only not the last problem because those two numbers are the same. I said, all right, so the last example, you said when the variables cancel out, the answer is false statement. But
so we had, so before you do that, we had 2 situations that occurred before you come down to your answer. Your variables cancel and there was a false statement. So both of those criteria has to be met before you can come to your conclusion. See what I mean?
Okay.
So your variables cancel and then there was a false statement.
Okay.
If that those two, yeah. So don't look at those as separate things. Both of those have to occur before you say we had no solution. So this time our variables cancel and we had a true statement. So this time our answer is all real numbers. So both of those things have to occur before you can come down to your conclusion. So I'm glad you said that. I'm glad you said that. So most definitely, guys, make sure you hold true to that. If your variables cancel, that's one thing that occurs. But the second thing is what's going to dictate what your answer actually is. So if your variables cancel and you have a false statement, in other words, the two numbers are different, then your answer is no solution. But if your variables cancel and you have a true statement, in other words, both of those numbers are the same, then your answer will be all real numbers. Yeah. That means anything you plug into this equation will be true. All right. All right, make sure we are okay.
All right, hold on. So I got a question. All right, so on this 3x minus 12, how come we didn't just on the second step? How come you subtracted the 3x? How come you didn't just divide it by 3?
Well, now you can do that, but it wouldn't create the most efficient situation for you initially. Now, if you decide to divide by 3, now that works out okay in this one because everything's divisible by 3. But if this was a 17 instead of a 12, now you're creating a fraction that you wouldn't have had to deal with if you had just subtract your terms separately.
Okay.
Yeah. Okay. So the most efficient move is don't actually. Let me go ahead and put this stuff back, and then I'll show you.
And I'm sorry if I'm making this more difficult than it needs to be, man. I'm just really trying to understand what's going on.
You're fine with me. You just ask some questions. Or rather you get clarity before you just walk on off. You know what I mean? Get your clarity. So the best scenario where you would look to divide, especially for the problems that you guys have, is right here. When you have a single term, you just have your single x term. You cleared everything off, and now you can just divide cleanly and then get to your answer. See what I mean? I wouldn't look to divide.
Look, that's what I was talking about. That right there, that's what I was. That's why I was wondering why we didn't do that on the example problem before.
Right. So now look at, so notice, right, all we have is just one x term by itself on one side of the equation. So now let's go back to the one you asked about. Now at the place where we have 3x, we have at each time that 3x is this, 3x and x terms right here. Then we have x term is over here. So what I'm saying is that I wouldn't divide unless I had this, just my single x term on one side of the equation by itself. There's no other x term over here.
And that's because you're just trying to get rid of the 3.
Right, right. See, you got a whole bunch of other stuff to do other than just trying to get rid of the 3. You see what I mean? But once you get to this step, then the only thing you're trying to do now is get rid of the 3. And then that will be the best place to go ahead and divide.
Man, I'm still to the left on this, but it is.
Hold
But
on.
we can move on, and
Okay.
then I'll come back with you after.
All right, hold on 1 second. Yep, sorry. So let's see. So, but if you want to ask more questions about it, I can, see what I know I was supposed to be talking to you before we close out anyway. So we see if we make sure you're straight. So somebody asked this class over. I think, yeah, because that's the next section. Yeah, so that's it for the lecture. I know I need to stay back with Mr. Tucker and I'll talk to him about a few things. But if you are good and you're done, then I will see you guys on next class. Yeah, be safe. I'll see you next class. All right, everybody take care. So now, let's see what's going on. No problem, thank you. All right, so Mr. Tucker, yeah, so it's really, just going back to that division thing, like if I were to divide at this point, because I think this is where you're saying divide right at this step after you do your distribution.
So right on the second line where it says 3x minus 12 and 3x minus 12.
Right.
And
so yeah.
Why aren't we just trying to get rid of the 3 is what I'm saying.
Well, the most efficient way to handle it is to try to get all of your terms with x on the same side of the equation.
Okay.
Yeah. So and then when you get to that step, that's when you'll divide.
Okay. So the reason that I'm not dividing it by 3 is because I would be creating unnecessary steps to get to the same answer.
Yes. Now you can still get to the same answer, but you're going to create more steps for yourself.
Okay.
And you will create something that may be more complex than necessary. Yeah.
Okay. I understand that now. Let me finish writing that example down because I was trying to get.
There you go.
3x minus 12.
Hey, it's me. How you doing? You know, I got a question, right? When you finish.
What's up? What you got?
I'm so confused with this whole decimal thing. You know, where you put the 10 in front of the numbers? It's like a mental block. I wrote it down and it still looks foreign to me, so I don't know what I'm doing.
Now, I will say this. I did that just in case somebody wanted that option, but you don't have to do it that way. You can just, and I know he's still copying this, so I won't scroll up yet, but you don't have to do the multiplying by 10 thing. You can just solve it the way you have it and still get the same result.
I just still don't get it.
Okay.
I'm right there with you. I don't get it all neither. Don't even worry about it. All your questions helping me too. Go ahead. You go ahead and do what you got to do.
Tucker, can I scroll up or you still copying?
Yes, I'm good. Thank you.
Okay. Let's go to that problem. Oh, right here. So now talk to me. What part of this that you say you had trouble with initially?
I mean, if you could just explain the whole thing all over again. I mean, either way, I just don't understand it.
So right here is the original problem. And what I was saying is that you really could solve this the way it is. Like if you just wanted to add 6 both sides, combine it, you know what I mean? You could really do it with just the decimals and it still would be fine. I was saying that if somebody wanted to clear out the decimals, or if for some reason my math lab asked you about clearing out the decimals, I don't even know if they will. This is one, this is one of the options. So you would multiply each number by 10 because you're trying to get rid of this decimal in the 10th place. And so 10 times 0.1 is 1. 10 times 0.6 is 6. 10 times 6 is 60, and then 10 times 19 is 190. And so now you no longer have any decimals.
If I stay with the decimals, you think that would be easier for me? Because
Well, that's all about preference. Yeah.
can you work it out like on paper with the decimals?
Yeah, so what I would do is combine these like terms. So that would be 0.7x minus 6 equal to 19. So that's the first thing, combine your like terms. All right. Then from there, I would add 6 to both sides. So that'll be 0.7x. And that shouldn't be 0.7, I'm sorry. I added those, that should be a -5, -0.5, I'm sorry.
Oh yeah. It looked right to me. See, I told you.
Yeah, you were supposed to catch it. It'd be like,
Hey,
Mr.
I
Tucker,
caught
you
it.
wrong.
I caught it, but I won't go say nothing because who am I?
Oh man, don't do that.
I didn't want that.
Don't do that to me, man. Don't do that to me. No.
I'm being honest.
Yeah, if I'm wrong, I'm wrong. It's all good. Well, I'm not that type of guy. You know what I mean? So yeah, if y'all catch something, it's all good. I'm losing my voice. I've been up since whatever time teaching classes. So look, man, numbers start to run together for everybody. So now I'm looking at -0.5x equal to 25. And you notice that's similar to what we have right here, just that the decimals are involved. So now divide by -0.5. And that'll be your 50, your -50.
Oh, okay.
So it's the same thing if you keep the decimals. I was just showing the option that you can clear out your decimals by multiplying everything by 10. I think the book even showed that as an option. So I just wanted to make sure that if somebody saw it in the book, they at least saw it from me as well. So
Awesome.
keeping the decimals, and just working it out with the decimals, you still get the same answer.
I guess I need to work on that then, huh? Thank you.
But any problem you try and you get stuck on or whatever, you can always bring it to class and we can walk through it. It's not a big deal. It's not a big deal.
All right. Well, thank you.
Not a problem. Not a problem. All right, Mr. Tucker, you said you had some symbols you wanted to know about.
And all of the symbols on the calculator, like any one of them symbols on the calculator, like I didn't know what the square root sign thing is. You see, I'm calling it a square root sign thing because I don't know what the name of it is. You know what I mean? And
right.
And the problems, like on some of the questions on some of the homework, is write this in word form or write the word form and I don't know what it is.
Do you know what kind of calculator that you have?
I don't have a calculator, but I know that some of these signs are on the calculator to perform functions, and I don't know how to use them.
Right.
And I would like to. I just want to be able to, because I don't want to miss the whole. If there's a section of 10 questions on the test just about converting word into number sentences or algebraic expressions or however you want to verb it out, I don't want to miss those because I don't know what's going on.
Right. Trying to think of the best way to get you in there. Because what may be good for you is for you to buy a calculator. And then from there, you tell me what calculator you have, and then we can start looking at the symbols. I can look at a picture of it and we start looking at the symbols and start matching them up with words and operations. And then that way you can start playing with stuff too on your own after you know what these symbols mean. You know what I mean? And then that'll be something to familiarize yourself. You have something visual in front of you versus me saying this. So, and it might, and then it would be beneficial. Then, like I said, you can just be playing with stuff just to get you familiar with it. That's what I would suggest. And you don't have to go get nothing crazy like a TI-85 graphing calculator and $100 calculator. You can get, $20, $30 calculator, maybe even something cheaper from Walmart. Just a simple scientific calculator that has.
It doesn't matter what brand it is. Like what would be the one that you would recommend that I get? Do you have one?
Texas Instruments normally are fine, but like I said, I'm not talking about 80, 90. Texas Instrument 85 or 81 or anything like that. Like I think they're like 30. I'm talking about it's like a brand number, the like model number TI-30 or TI-28 or something like that. Where it's not too expensive, it's not crazy expensive, but it has all the functions that you would need and that you could see moving forward. And like I said, you want to make sure it's called a scientific calculator Because let me ask you this: are you going to a higher math after this one?
If my degree path, I think I am. I'm pretty sure I am. I'm pretty sure this isn't the top. That's why this is so crazy for me, because this is just the beginning. This is supposed to be the basic, and I'm already, you know what I mean? Like, okay, all right, because I get some of this stuff. You know what I mean? I know how to do all of this stuff. I just don't know how to word it.
Right,
and
right.
Understand it like you guys want me to understand it. I've been applying it for years.
Right.
You know?
Got you. So yeah, there's nothing wrong with that. So we'll make sure you get caught up and get a break. What's your major?
I'm going for small business management and entrepreneurship, I do believe.
Okay, I was trying to figure out if I knew the math track that you would be on, but I'm not sure about that one.
I can tell you right now. I got my thing right here.
Okay.
So a math 130 or higher, and then I gotta get I think that might be it, because marketing, everything else is business.
Okay.
Business finance, I guess. Yeah, financial management for small. I don't know if that's a math class or not. I'm not sure, man.
Right. Well, it's probably not a straight math. You know, it probably doesn't have MTH in front of it, but that doesn't mean it's not math. I won't say math heavy, but that doesn't mean you won't need the math. You know what I mean? So yeah, right. So that's what I would suggest. Like, go to Walmart or something like that. Get you a solid scientific calculator, so we can make sure you're good on the symbols, and then it will give us something to reference. You know what I mean? Versus just saying these are the symbols, but that'll give us something to reference and stuff like that.
And at that point, I might be able to just navigate it myself. I was just trying to get you to like point me to. I don't want you to walk me through everything. I just wanted you to point me in the right direction to where I can help myself, because I'm good at that. I can. Yeah,
I most definitely would suggest that then, because sometimes just playing with stuff just gets you like, oh, that was division. Like, you know what I mean? Like, you know what I'm saying? Like, just playing with something in front of you will most definitely help you get familiarized with the symbols and stuff like that. And then if there are any symbols that you see that the book is using that you don't quite see on the calculator or whatever, you know, saying, always feel free to shoot that to me in email or take a picture of it. Shoot it to me in email.
What book are we talking? I thought we didn't have to get a book.
In math lab, you have access to your e-text if you want to use it.
I didn't know anything about it. I've never seen that.
Yeah, let me see. So you
I actually bought the book at the bookstore probably about 2 weeks before class, or however long before class, a few days or whatever. So I have a book, Math 130. But I've never taken it out of the plastic because I don't know what page we're supposed to be on. I'm just following along. It's hard enough trying to follow along with what you got going on. I didn't know we were supposed to be thumbing through a book at the same time.
Well, no, that's just completely up to you. You don't have to. I mean, if you want to take the book back, you could. I mean, but you know, right here, and you can see my math lab right now, right?
Yes, sir.
So what you either click on e-text, and that'll take you there if it don't take too long, or chapter contents, and you can go to the chapters, and it'll go to where the book is located. Let me see. We just was in 3.1. If you go e-text, if it doesn't take forever. So it takes you straight to the book where that is located, and it's the exact same thing as as the book and everything. So yep. So that's why, you know, when I sent you guys that email, tell you didn't need the book. And see here talking about like and unlike terms. Yeah, so that's why I say you didn't necessarily need to purchase the book unless you just wanted to have a hard copy in front of you, because you have a copy of that book in your e-text.
Okay, awesome, man. Awesome.
So that's why I'm saying that, yeah. And then as far as pages, I wouldn't go by page number. I would just look for the section. So, you know, we're teaching by sections. So like I just did, I went to 3.1, and then it'll go there for you, and you know, so you don't have to worry about the page itself.
Okay. I'll definitely navigate through that and try to find out what's going on. I'm gonna get that calculator. I'm gonna try to educate myself on that, and I'm also gonna keep going, trying to go a little bit forward and testing my knowledge as far as the homework assignments and whatnot, and just to see what I don't know. But yeah, I appreciate everything, man. I appreciate you slowing it down for me. I appreciate you dumbing some stuff down for me. Anything anything you can anything you can do to help me, man. I appreciate it. Thank you very much. And I'll see you next class, brother.
Most definitely. You take care, man.
Yes, sir. Be safe out here.
Yes, sir.